Okay, I guess we'll get started. Can someone on Zoom confirm that you can hear us?
Yes.
Okay, great, thank you. Welcome, everybody. Welcome to the round back session on the Rubin Observatory carbon footprints. This is a reminder to follow the code of conduct during the meeting and how to participate to the session. The slides are all posted on the agenda. So today we will talk about the carbon footprint of the observatory. I will start with a short context, and then Bob will talk about all the work that has been done at NOIRLab to estimate the footprint from the summit. And then Fabio, who I see online, hi Fabio, who is going to talk about the footprint of the data facility in France. And then we'll end with some discussions. So first, I wanted to start with some context because I think, you know, talking about carbon footprints, we're actually talking about the climate crisis and climate change in general. And I just wanted to bring up some things to put that into context. So first of all, as you're probably all aware that since the end of the 80s, the IPCC has been doing multiple reports, and every time showing that the climate is warming up more and more and faster and faster. So it basically communicates that we have to act extremely urgently to limit this global warming. So here there are different scenarios of the future of the global temperature, and some of these scenarios are really catastrophic for the ecosystem. The food production basically will impact our life really badly. And then there are more optimistic scenarios that necessitate us to take action to limit our impact on the climate. Something I wanted to mention as well that's really important is that when we are talking about the climate crisis and how climate change impacts us, we are also talking about that it's also an issue of social justice, as it's shown in the IPCC reports. The most vulnerable populations, the people who will be most impacted by climate change, are actually the people who emit the less. And the richer people are the ones who emit more. And a very clear example, for instance, is how women are will be more impacted by the climate crisis than men. And I linked some reports here if you're interested. So why do we want to talk about climate change as astronomers? So first of all, we are using resources, millions and millions of dollars. We are using lens like the summit for the telescopes, and we are using a lot of energy to take our data, process our data, and analyze them. So we have a responsibility to think about how we use those resources and how we can use them responsibly to limit our impact on global warming. And actually, there is an overall effort in astronomy, and one of them is this Astronomers for Planet Earth movement, which actually I'm not a part of, but I wanted to mention because probably some of you want to join it or are in it. But to me, some of the points that makes it important for astronomers to talk about climate change is that we understand how special Earth is and how frail life is on Earth. And we can also use outreach as a tool to educate people about climate change and the urgency to deal with the climate crisis. And because we are such an international community and that we are kind of, working together, we have the power to change our mindset and kind of drive the change in how we perform our job to limit our impact. So all of this is to motivate why we want to look at the emission of the greenhouse gases. So while we are aware that, curbing climate change is a multifaceted effort, reducing greenhouse gases emission is really one of the very urgent actions that the IPCC recommends. And here, this is a quote from this paper that's who estimated that the total infrastructure in astronomy emits 1 million tons of CO2 equivalent per year. So that's already a lot, and actually that's what is driving the emission of astronomers, is actually using observatories. And I just wanted to put something in comparison that still we are doing much better than other like big emitters, but still we can lead by example, and we have the power to change what.
Agnès, can you say something a bit more about the infrastructure mission compared to travel? I mean, when I first started thinking about this, the travel seemed to dominate, but maybe something has changed in the last couple of decades.
Yeah, so this was based on both ground. So they looked at all the astronomical infrastructure that includes space-based and ground-based observatories, and they computed the emission over 20 years, and then that's what you got per year. So it's not clear, yeah, because so here and other people have put a report maybe like 10 years ago about the emission from, or like the energy consumption from astronomers, which is a very interesting risk. But I guess maybe there are more infrastructure or there are more computers intensive, but it would be nice to dig into it. But yeah, like if you divide that in between all the astronomers, I think this is still like a huge factor. And also, I just wanted to mention quickly the pitfall of just talking about the carbon footprint. So some of you might know the origin of the idea of the carbon footprint was actually proposed by an oil company. So that's extremely cynical. So that's an example of the tweets that BP makes to compute your carbon footprint. So what they are doing here is that they're actually blaming us, like individually, like they're blaming our actions. But actually, when you live in a society that's based on fossil fuels, it's like almost impossible to reduce your emissions. I also find that it's, climate change is a deeply like human problem. It really impacts our life. And by looking at only the carbon footprint, we kind of focus on numbers, statistics, and we do math and stuff. And then we kind of forget about the human aspect and how it impacts us in our lives. And it also focuses on greenhouse gas emissions and not necessarily on the impact on ecosystems and things like that. But it is an amazing starting point, I think, and it's also unneeded as a starting point to estimate the carbon footprint, because it will help, see where we need to make more efforts towards limiting global warming. So with that, I will let Bob now talk about the Rubin footprint.
Great. Thanks, Agnès. So I'm Bob Blum. I'm the Rubin Observatory Operations Director. I hope I've met most of you or some of you here. Glad to have you here. Obviously, we got some work to do. This is a pretty small fraction of the folks at this meeting. It's a pretty important topic. It's important to all of us, and I hope it's important to you. And we're trying to do some things as we go forward to really understand what our impact is and find ways to minimize it or to reduce it. And I'm glad that Robert Makuta is online. And Robert is one of the folks at NOIRLab that has done a lot of the actual work here. I'm really just sharing work that he and Inger Jorgensen at NOIRLab and others have done to bring us along to this point. We have at NOIRLab actually embarked on a plan to reduce our footprint and to switch some of our energy generation at our observatory sites to renewables, to reduce travel, to modernize our buildings and systems to conserve energy, to add electric vehicles. If you come to Tucson now, we have some electric vehicles there. We have some electric vehicles in Chile. So it's really a multi-pronged approach. I think Inger would remind us that it's not just about immediately switching to renewables. There's lots of things we can all do to make our use of energy more efficient. We should talk about travel a little bit more today too, because that's a big deal, and I'm wrestling with it personally, and I think others are in our community. You come to a meeting like this, and it's just so exciting and engaging and invigorating to be with everybody. But there's a cost, and so how can we balance those two things? Come out with something that pushes us in the right direction. The NOIRLab specific program to reduce our footprint and reduce our emissions is consistent, and I think even goes further than what was in the US Decadal Survey in 2020 that also called on our community to try and address some of these issues. But we're certainly glad to see it brought up, raised as an important topic there. And we're trying to encourage everyone, and I think many people are there are many people of goodwill in our community, not just at NOIRLab or SLAC, but you're going to hear from other folks in the Rubin sphere. Lots of people doing things. So this is a long-term goal. I think we can't take our eye off of it. We need to steadily make progress, and I want to show you some of the progress we've been making at NOIRLab. So our goal is to reach a 50% reduction in the footprint relative to what we assessed in fiscal year 2019, and bring that level down by 50% by fiscal year 27. So just another couple of years, and I think we've made good progress, but we haven't made all the progress that we might want to see so far, particularly travel. This reduction would be 6,200 tons of carbon dioxide equivalent annually, so that can be compared to that megaton value that I said. But that's also just literally at the activities and infrastructure supporting at NOIRLab. It's not with all the community that we can that we collaborate with. It's not their travel. It's not travel that they do to come and visit us or go to our mountaintops and that kind of thing. Question?
Yeah. What's PV?
Oh, photovoltaic. So these are just the solar panels that we're deploying. We have funded a series of photovoltaic programs that will be, it's kind of one of the centerpieces of this overall program. And we're deploying those systems and have been deploying those systems for a number of years. Gemini Observatory actually started doing this in Hawaii and in Chile as early as 2015, and getting up to about 20% of their energy needs. And we're currently embarked on a program between Gemini and Rubin to make all of the local on the mountaintop in Chile energy renewable. So full solar system panels that would accomplish that hopefully within the next year. We're actually involved right now in designing that system. We've secured the funding for it, and we're starting to actually purchase the hardware for it. There's many other things. So there's battery systems associated with that so that we can run 24/7 and not have to switch back over at night. There are other infrastructure changes happening at our facilities. For example, in Tucson, we work in a 1950s era slump block building with single pane windows still in many places. We've actually started changing those out for double pane windows and a very old inefficient air conditioning system. So we've also secured funding to make those changes, and we'll continue to do that. There's many even smaller things you can do, right? There's many efficient light fixtures and things like that, automatic dimmers, automatic light switches that turn the lights off when people don't use them. There's plenty of things that can be done that don't require a large photovoltaic system or something else to make a difference. So we're trying to hit all those things. And this just shows where those reductions will get us to, in this case, by 2040. So this is a long-term program. The initial goal was 50% reduction by 2027, but we want to continue and work going forward so that, you know, we have very, very small carbon footprint residually by the end of the, you know, by the time we get out a couple decades.
So, Bob,
Yeah.
I mean, this one thing I got to remember when I do my public talks is that the rate of reduction as well, that 50% in 5 years is kind of remarkable. You don't hear too many organizations around the world talking about reducing their emissions by that factor in such short time.
Thank you. I guess I would say, yeah, maybe that's part of the problem, right? It sounds like a really big deal. I think it's doable, and so we shouldn't let, you know, these big goals slow us down. And if you talk to climate scientists, they are telling us we need to make, you know, this isn't an incremental thing. We need to change our behavior or what we're doing rapidly. So yeah, I think we can well, I certainly applaud the leadership and actions of people like Robert, who's online, and Inger, who's been leading a lot of this at NOIRLab. But you know, we have to do it. That's where we're at. And the other part of this whole thing is none of our folks from NSF or DOE are here right now, but without their support, we wouldn't be able to even see it. We have a tremendous amount of support in the last few years from NSF, in particular on the NOIRLab side, providing supplemental funding and allowing us to use savings in our travel budgets ongoing to put that back into the infrastructure plans that we have here. Without that support, which is significant, we wouldn't be able to do that. And there's other groups that don't have that, aren't able to quickly switch because they don't have as much funding as we do. So we're trying to make you know, on behalf of all of us, we're trying to make a big difference. I think we'll hear about computing facilities soon. That's the next big issue, right? How do we do all this computing? And our computing ambitions are just growing immensely in the last few years, based on what we think we can do with data and artificial intelligence. So how do we work together with providers of that resource to try and do it in a more sustainable way? I think that's a huge question. Anyways, this plot just shows some of the funding that we've secured and how we hope to deploy it in the next couple of years. So really, we do want to get this system up and running quickly in Chile on Cerro Pachón, where the Rubin telescope facility is. Rubin is a particularly big user of electricity, actually, right? If we hadn't had the photovoltaic panels, we'd be using even more energy than Gemini, for example, because it is a big, heavy telescope that moves extremely rapidly, constantly throughout the night. It also has significant needs for conditioning the air during the day and keeping the dome environment stable. So it's a large system, but we think we have a plan now. Fortunately, the cost of some of these solar panels and things has come down, and even in the time we've been planning it, so even the initial resources we had look like they'll go far enough to get all of our energy generation and storage needs for everything on Cerro Pachón. That's all the telescopes. That even includes the SOAR telescopes, so SOAR, Gemini, and Rubin. And we're doing it in a combined way, so all the power generation is done centrally and then sent to the different telescopes. So look forward to sharing the progress as we go forward and how we're going to when we turn that on, showing you how it's doing in the next couple of years. I don't think I have a slide in here, but you could go online to NOIRLab and you can find some nice images of where even maybe a video simulation of where the panels will be up there on Cervachon. Pretty cool. The program across NOIRLab, funding comes from our base funding and supplemental funding, as I just said. The sustainability program, we've actually assigned a chief sustainability officer at NOIRLab. That was Inger Jorgensen. She's retiring this year and passing that off to a person called Brittany McClinton, and Brittany is taking over and will continue leading this project as we go now through we've got through the funding and the design stage, and now we're going into the implementation stage. And we've also assigned a project manager. So this was support from NOIRLab leadership to bring significant resources to actually do the work, because it's a big construction project. There's a lot going on, both physically on ground and then, of course, electrically, and to get everything up and running, and of course, to maintain it going forward. This is just an overall block diagram that shows the level of the footprint and where we're currently addressing it with the hatch region. So overall, those boxes are proportional to the amount of energy we use in any particular place. So I think this is the original design, and I think it gets to 100% now. So we still have a ways to go to cover up the rest of these things. The interesting part of this is just to show how significant our staff travel is as a function of all this. It's not the majority thing, but it's not tiny either, right? So we want to keep working on getting the reduction done. And then this shows not only Chile, but what we're doing in Arizona. I think Robert may have been one of the ones that did some of the calculations that showed. Yes, question.
So I have a comment. Maybe it's going to sound a little bit rude. I don't know, maybe. So I think there is like a lot of emphasis, or that's the feeling that I have, a lot of emphasis on the reduce the travel.
Mm-hmm.
And I think it's a little bit like selfish and hypocrite, because I don't think that in NOIRLab reduction is going to affect the people that travel the most right now. I think it's going to affect maybe the people that only travel like once, maybe every year or every 2 years, but it's not going to affect the people that maybe make most of the rectangle that is there. Yeah, that's like an opinion.
You
that I
mean
have.
if we implement a travel reduction program, what it's really going to do is adversely affect the people who rarely travel.
Yeah.
And the people like me who are in leadership positions travel all the time, and I'm going to keep traveling all the time. Yeah, you're probably right. And I think that is an important point to make as we go through this. You know, one of the things we can talk about in travel is we can all agree that travel is good. I'll get to you in just a second, Robert. But you know, maybe we alternate travel. You know, maybe I go to a meeting one year and I don't go to the meeting the next year. But you're right. We have to make sure, especially for our young folks and people who are just starting out, that they have the opportunities to meet people and do the things that they need to do. Very, very good point. Robert, go ahead.
Yes, hi, can you hear me?
Yeah.
Thanks. So first of all, thanks very much for this wonderful presentation, right? And such an important topic. First comment was that I'm not sure why so few people decided to show up to this session, right? We had a similar experience at 1 or 2 AAS meetings ago, where we had a special climate session there, and maybe 30 to 40 people showed up out of 3,000 people coming to that meeting. But our excuse was that, you know, there were 25 plus competing sessions at the same time. So, you know, people go to what they need to go to. I think the people interested in reducing climate gases and reducing our carbon footprint, people who are here in the room, they know why they're here in the room, right? But I think we need to advertise more and kind of make people aware, our colleagues aware how bad it is, what we are doing. Just to give you some numbers that you mentioned, Bob, right? I was involved with Inger in computing the travel carbon footprint, and also now in adopting a carbon footprint reporting tool, like a standardized one. What we found, and compared to other places who have done similar things for their institutes, is the carbon footprint per capita that NOIRLab is producing right now is 19 tons per year. If you compare it to what an average American produces, it's 14 tons, and that's already 3 or 4 times more than an average European. So on top of our carbon footprint from daily life and the badly insulated houses we have in the US, each of us produces 19 tons on average just from going to work. And that does not include any kind of construction projects like Rubin or other future construction things. So we really have to think about it. And then back to, I don't know who asked the question just ago, 5 seconds ago about travel, right? That it adversely affects people who travel less. The kind of reality is that you can only be responsible for the carbon footprint that you produce. Maybe you have some leverage on the downstream and upstream things, buy from another manufacturer and so on, but the travel you do is the travel you do. And I agree, as an organization, if we reduce carbon footprint from travel by saying you cannot go to 2 or 3 international conferences a year, that should be probably skewed in favor of young researchers, of people just starting out, right? Because that benefits the most. But overall, as an organization, I think even though our total carbon footprint is probably less than what Taylor Swift and others are flying in a private jet per year, it's still the thing that we're responsible for. And the kind of, my final point is, the kind of outsized outreach effect that astronomy has, is one of the most positive sciences out there, most popular. There's only good news from astronomy, or never catastrophes or anything like that. We can also benefit from, or we can push kind of more this message by making climate change and the effort we're doing a very important part of the message every time we speak about science and about the other things that we're doing. Thanks.
Thank you, Robert.
Before going to Noah, I was just thinking, can anyone take notes of the discussions? Because I think some of the things we discussed we can use for the future, because my computer, I can't.
Are we recording?
No. Okay.
We are recording.
Awesome. Thank you so much. Okay. Great.
Noah, go ahead.
Yeah.
Sure, thanks. Yeah, I also want to thank folks for coming and for running this session. I think it's quite important, as I think we all probably agree. I think Robert made some really excellent points. One thing that has been really useful for me to try to put these numbers into context, which I think helps to motivate, is, if you took the sort of carbon budget that we have, accounting for sort of carbon sinks, and some of the recent astronomy papers in Nature have done this nicely. It comes out and distribute it to everybody, around the globe equally. We each get about 2 tons of carbon per year. And so I think that's, it can all get lost really easily when thinking about avoided emissions that we otherwise would have done, but having a target is actually really useful. And I think that 2 tons is really clarifying in terms of thinking about, that's about how much gets burned with a single transatlantic round trip flight. And so that should cover all of the food, shelter, heating, cooling, all of the goods you use, everything. And so I think that really puts into perspective the massive changes that, taking this problem seriously kind of implies. And I think that the sooner we can kind of clarify for folks the magnitude of the changes we're talking about here and the importance of sort of being proactive as a field at implementing ways to sort of continue to do the science that we're so, passionate about, in a way that maximizes our ability to do that while meeting these global commitments and these global demands, the sooner we're going to get more and more people showing up. Because I think when you tell somebody that basically you get 1 flight a year for every, and that's it, now all of a sudden people start to pay attention. And so obviously we're not going to jump to that immediately, but I wonder if, I just think that that's been a useful number for me to keep in mind, and for putting some of these numbers in context. And in particular, on the travel front, since that's where I think it touches people directly, I think a ton of work, hard work is going into the infrastructure on the back end, which is really crucial. And it's really this travel piece for which astronomy is one of the worst offenders, which is really hard to tackle. And I wanted to ask Bob if there were more that hatched region for travel reductions over the next 3 years. How much of that is there is that an evidenced, is there a plan for how to actually achieve those reductions? Or is that just sort of a goal and they're still working out plans? And I'm curious about, how that actually looks in practice when planning that out. Are you looking at just sort of the worst offenders in the sense of in terms of the amounts of flights that they have and curtailing those? Or yeah, can you say a little bit more about how that 50% hatched region is planned to be achieved?
There is an actual plan per se, but it's really just a simple linear reduction in travel year on year until we hit the 50%. So that sets a profile over the last since 2019 to 2027 of the amount of travel we would have to do less. And so we're actually looking both at our actual expenses. We use actually money planned and money spent as a proxy for travel. It's not perfect, but Inger has shown in certain ways that it can be useful, at least if you have an understanding of where the people within your organization are traveling. You can make certain assumptions that then the money you budget and the money you spend are a good proxy for carbon. So the sad fact is, so we have the plan. The sad fact is we're not hitting it yet. Rubin is a issue. Part of the issue is that when we put this plan in place, or when we stepped up to the goal, we didn't know the pandemic was coming, and you could imagine that in this period we have a lot of needs to get people back and forth to Chile. We have a lot of needs to train up the community and do other interactions before the survey starts. Those got pushed off. So we essentially did no travel in the early years of this plan. And now we're getting back to traveling, and we're not hitting the current goal. We're over for next year by about 40% at NOIRLab. So it's a big issue. I need to work on it with my staff, but I don't have a magic bullet yet. And before I move on, it may be that Robert wants to contribute to this particular thread. So I'll let him jump ahead of Andres. Pardon me, Andres.
Thank you. Yeah, and I'll just take 30 seconds. So Bob, you're correct. We saw the numbers. The money spent on your flight ticket is a very, very tight predictor on the CO2 footprint that you will generate. Airlines mostly charge you for the fuel, right? The cost per plane that they had to buy and everything, that's divided equally between all passengers. And the second thing is just to back up what Noah said with numbers. I looked it up. So if we as a planet want to meet the Paris Agreement by 2030, each single person on Earth must produce no more than 2.7 tons of CO2. One flight to Europe from the East Coast and back is about 1 ton. So 2 to 3 flights and you're done with your footprint. So this is really a very tough problem. Thanks.
Agnès, did you want to say something before Andres goes?
Andres goes, and I'll work.
Go ahead, Andres.
Are you done with your presentation, or should I wait until the end? Sorry.
It's up to you. We have a few more slides here, and then there's more presentations after me, I think.
Yeah, but that's interesting discussion.
Well, okay, just very quickly, I just wanted to ask, maybe, sorry if I missed it. I think it's great you're showing us the site from NSF and NOIRLab, and I was wondering, I guess this is a question for you and for Phil, if there are similar quantifiable efforts that are being done at the DOE and on SLAC, or something that we can do from the SLAC point of view and the DOE.
But the short answer is yes, and Agnès is one of the folks that's starting to work on that. But the issues and the impact are somewhat different from the DOE side, so we haven't got the comprehensive view of it yet. I don't know if you want to say any more on it.
Yeah, we have a quick slide about it at the end, but yeah. There's not much, like, even estimating where the energy is coming from at SLAC is really difficult. So yeah, I think there is a lot of work that needs to be done.
Okay, let me get through the rest of these slides and we can move on. This is just a nice high level, literally a high level view of the summit in Chile, Cerro Patron, and it shows the Rubin Observatory, Gemini, and SOAR telescopes that are along this ridge, and then down below this ridge to the south is where the photovoltaic panels will be installed soon. That's just a blow up of the area showing the different places where we've now designed that we can put the panels as we fill out the full complement. And then there's a more concentrated area, of course, where the the batteries are and where the energy distribution can happen. This is an interesting slide. I won't go through all the text. It just talks generally about the resources that we're doing, but you can get those are real pictures from the ground looking up toward Gemini where the panels will be. I think this is a really interesting low impact way. One of the things Robert mentioned, which is of course true, is I'm talking about being carbon neutral for the energy we generate while we observe. Of course, there was a big carbon cost to actually build the observatory. All the materials that go in that construction is very intensive. This is a way, and I think we're still on track to use it. These large screws can actually just be screwed into the ground and hold the solar panels rather than putting in cement footings, for example, which cement is very expensive with respect to carbon, and it's even more impactful in a construction way on the environment. So these large screws, we're doing tests. They literally look like regular screws, but these things are huge. That's a 1.5 meters long or something. They get screwed into the ground very simply with a lower impact. And then the question is, when we load them with the panels, which will have wind loading on them, will they be sufficient? Okay, that was all I had. Happy to continue to have questions, but I guess we're going to move on to Fabio Hernandez, who's at the French data facility. He's going to talk about some of the efforts on that side of the Atlantic to make progress too, of course, because this is a global problem.
Thank you so much. Any last? Yeah. Thank you. I think we'll do this talk and then we'll have discussion at the end. Yes. Yeah, but any quick question just before? Oh, okay, Fabio, take it away.
Okay, do you move the slides or do you want me to share?
I'll move the slides.
Okay, good, thank you. So good afternoon, evening. Hello to everybody. My name is Fabio Hernandez. I am the lead of the Rubin French Data Facility at IN2B3, and I am based in Lyon. So I was invited by Agnès to provide some inputs to this discussion. So I went and collected what we are doing at IN2B3 about this, and this is what I am trying to report. Most of the work of the measurements that we did were done by my two colleagues, Xavier and Stefan. So all the credit goes to them. So next slide, please. Okay, so let me put a little bit of context of this subject, what is happening in France. So France published its low carbon strategy, which is basically a roadmap to mitigate the climate change issue, and in particular to meet the commitments made by France itself and by the European Union about the Paris Agreement. So it is 2015. And so basically, very concretely, the goal is to achieve carbon neutrality by 2050. So carbon neutrality means here the balance between the emissions made by humans and the absorptions also made by humans. And then concretely, all the entities, and in particular the governmental entities, have to report every 3 years at least, their assessment of their greenhouse gas emissions. So this is for small companies that's not that doesn't apply but basically all the entities, even private and governmental, have to do that. And the goal is that all this reporting goes with the same methodology, and then there is a governmental agency that collects all those reports and publishes them. And really, they are really public, so you can go and see them. So IN23 is a governmental agency. So we did our mother organization, which is CNRS, depends of the Ministry of Research. So we have this legal requirement as well. Next slide. So this is basically the goal. So very linear. This is France's goal. So basically we have for every 5-year period a carbon budget that the country sets for itself. And until 2050, in which the minimum, as stated by the government, is that the minimum that emission will be 80 million tons. So that needs to be compensated by the absorption mechanism, either natural or human-made. So on the right, you see the concrete targets in million tons. And on the table, on the bottom right, you see the annual evolution that is needed to reach those targets. So this 7.5% of reduction per year needs to be compared to the reduction made over the COVID period, which was 6%. So that's is a good comparison to see the problem we have in hand and to solve. So this is an aggressive goal. And then we need to contribute to that. So next slide. So in 2022, we, Computer Center of IN2P3, which is the entity which operates the Rubin data facility, did a first assessment of the emissions that we did in that particular year. For doing that, we used a tool made available by a collective of academic researchers called Labos, like Laboratories 1.5. And the goal for this entity is to collect and to study how the greenhouse emissions are done in the country, in particular by laboratories. It's not limited by laboratories, but this is the point they are interested in. So we use that tool that helps you basically assess your emissions based on some methodology that they published, and it's a very transparent process. And that includes the emissions related to buildings, the purchase of goods, the computing equipment, which is very important for us, vehicles, commute, business travel, food, everything. And then those results are published in a standardized way, which is the JHH Protocol Corporate Accounting and Reported Standard, and that you may be aware of. Next slide, please. For those who are not aware of these categories of emissions, basically this standard classifies the emissions in 3 categories. The Scope 1 are the emissions that you directly produce as a result of your activities as an organization. So for instance, us as a computing and storage service providers, we need to consume electricity to do that. So this is a direct emission. The Scope 2 emissions are indirect, and those are made by the fact that we need to purchase electricity, that we need to heat, we need to cool the equipment and all that. And the Scope 3 are the emissions resulting from, for instance, the IT equipment that we need to purchase. So we don't emit that ourselves, but we purchase equipment. So for fabricating this equipment, the providers need to emit gases. So those are the 3 categories, and I am mentioning this because in the next slide, I will show the table with the quantified results. So these are the quantified results for IN2P3 in 2022. So the big picture is 2,000, a little bit more than 2,000, but let's say 2,000 tons per year. And it is interesting to see the three scopes, because the discussion in this meeting has been focused on travel. And travel is not the problem for us. I mean, it's not a big problem as the other ones, of course. So the main point is the scope 2. This is about 21%. And this is basically the direct consumption of the electricity we purchase. And this takes into account the France electricity mix. This is probably why it is relatively low compared to the other emissions we do. And in the scope 3, we have the two first line, which are related to the emissions that we do by purchasing equipment, mainly IT equipment, but it's all the equipment that we purchase. And then the 11% in the third row in the scope 3 are the emissions related to extraction and transportation of the electricity that we consume. And then travel, business travel is 1%. Employee commuting is equivalent to almost 2%, let's say. And basically those are the big parts. So I found when I started studying those figures, I found that very interesting and at the same time very depressing. Because let's say that you install solar panels and you don't buy electricity. So basically we would reduce our gas emissions by 20% or 30%. So the problem is really not solved only by installing solar panels in our case. I have more comments in next slides. So to give you an idea of what we are talking about, so this is our building. We have two machine rooms. The machine room number 1, which we have been operating in 40 years now, almost, and the machine number 2, which is much more efficient because it was built is much more recent. So the efficiencies of those two machine rooms are not the same. The second machine room is much more efficient, and it hosts most of the equipment, but there is still a significant fraction of equipment in the machine room number 1. So we have the intention to retire machine number 1, but we need to build a third machine room. And this has consequences as well. So next slide. And this is a photo inside the machine room number 2. So basically it is a room without windows in which you install racks of compute equipment that are very noisy and that emit a lot of heat. So that's basically our machine room. Next slide, please. So the next question is, okay, so what can we do to reduce our emissions? I think that we already did what we needed to do for the low-hanging fruits. I mean, we changed the lighting, we improved the isolation of the windows and the roof. We are reusing the heat from the compute equipment to heat the offices, and even to send warm water to chemistry lab on the campus. So this is just a small fraction for us, but this is interesting for them. And on the front of electricity for cooling, we have been also doing several improvements, like being less conservative in the pressure and temperature that we are setting for the chillers. And we recently installed solar panels on the roof of the buildings. So you can see the picture in the next slide, and we will come back. So this is the picture of the roof, and these are the solar panels. So this is 680 square meters of solar panels. And that will allows us to produce 1% of the electricity that we consume. Previous slide, please. Okay, so all those improvements that you are seeing in the 3 first bullets allow us to reduce our emissions by 16 tons out of 2000. So this is the kind of depressing thing that you need to do a lot of things and still you don't reduce, in our case at least, much more our emissions. So I was mentioning that we need a more efficient machine room, and we have the budget and the plan to build it. In fact, the building process will start later this year. And the idea is that this machine room would be in operations late 2026. And it will replace machine room number 1. And that will help us improve our ratio of the electricity that we need for cooling. And then the reduction that we are going to reach with that is 20 additional tons, additional to the 16 that we already did. So again, you have to put a lot of effort and only 20 tons per year. But the problem is that the machine room will increase our emission by 3,000 tons for the year in construction. Okay, so we will operate this machine room for 30 or 40 years, hopefully. So that will help, but it's still the problem that the balance to make between the amount of effort you put and the real impact of that effort. Next 2 slides, please.
So just to ask,
Yeah.
why is it build a new room instead of reusing the same room? I noticed some times when people just build new things instead of like reusing, and it seems like that would be more efficient.
Yeah, it is a good question. Basically, it is technically very difficult to reuse the machine room that we have. We consider that, and we are using that machine room, in fact. But the problem is that it is not efficient, and we cannot do any much more of what we have did already. And one of the reasons is that this is a machine room with raised floor, for instance, that was built to host a mainframe. And at that time, the mainframes were cooled by water. So there are pipes of water under the raised floor for doing that. And you cannot keep use very effectively the electricity because you have to cool those machines, and this machine doesn't allow to do that. So it's a technical reason, in fact.
Thank you.
Next slide. Next, yeah, that one. So then we can focus on the other big part of our emissions, which are the equipment that we need to purchase every year to keep with the growth and to replace that equipment that we retire. So that equipment accounts for roughly 500 tons. So which are about 1/4 of the site's emissions. So this is not directly under our control, those emissions, but we did include some criteria in choosing the companies that bid, in our case, because we have to purchase the equipment on national bids. And a national call for tender, sorry. So we included that criteria as well. But we don't control it. We cannot certify, of course, that the providers are telling the truth to us about their own emissions. One of the things that we are considering is to extend the lifetime that we keep that equipment in production. Currently, it is basically 5 years for both compute and storage servers. We are considering extending that lifetime to 7 years so that we have to purchase less equipment. But there are additional considerations. Some of the providers tell to us, okay, I cannot guarantee your equipment. If it breaks, I cannot sell you spare parts, all that stuff. So it is, we have to find a balance. So currently we are in 5 years for both, in both cases. Next slide. The other part of the problem is that, okay, so we are serving several science projects. Rubin is one of them, but we serve other projects. And my personal feeling, I probably, this is not shared, or I don't know if it is shared by the management of I2B3, but I am persuaded that unilateral efforts to improve the efficiency and to improve all we need to improve only on the data center side won't be enough to reach those goals, as the figures really show. So I think that we really need to involve the science projects that we support to see what they can do on their side. So we started collecting data to improve the visibility of the energy consumption per science project so that we can talk to them and give them some figures about their impact, the impact they have by doing their science for the computing part. And in the next slide, you will see the kind of data that we are going to collect. So this is basically how much electricity we use for the computing, for the storage, for the infrastructures, which is basically cooling. And then we can see that per experiment. The science projects are on your right. So the topmost is Atlas, which is an experiment which takes data at CERN. The four most consumers are CERN experiments so far, because those are the biggest, our biggest customers in terms of computing resources. So you see the red arrow shows the consumption by Rubin that year, which is less than 1% for that year, but is going to increase as we enter operations, because we will need to purchase more equipment for Rubin. So this is a way of quantifying and telling for talking to the science project. Okay, this is what this is your emissions, indirect, but those are your emissions induced at I2B3. So next slide. So we are attempting to explore other ways. So one thing is, okay, we would like to exploit to the maximum the capabilities of the hardware that we are purchased and that we have to operate. One of the things that we are going, and this is specific to Rubin, is that we are trying to build tools to observe the resource consumption made by the execution of the Rubin pipelines. So we presented that project at the JTM this year at the SLAC, and see if to understand what are the sources of those consumptions, and see with the developers of the pipelines if we can do something to improve the situation. There is also new hardware that is entering into the market. In particular, there are some ARM-based CPUs. So this is the CPU architecture that you use in your iPhones and even in some laptops. But this type of equipment is slowly entering the server space. So those servers are that architecture is interesting for us because some measurements made in more or less realistic conditions by other sites like us show that they reduce the consumption by more than 30% compared to x86 architecture. So that sounds interesting for us. And we started purchasing some equipment like equipped with that kind of CPUs to see if we observed these kind of reductions in real life conditions. And the good news is that the data management team put some work on making sure that the pipelines run on ARM CPUs. So that's good, and thanks to the DM teams for its effort. I think that we need to incentivize the science projects to be more frugal in their computing requirements. More frugal means, okay, tune your code so that it can work faster or run faster, or reduce the consumption. In terms of memory, that means RAM and persistent storage. So for instance, if we don't need to store data, we don't need to purchase equipment. So the equipment that we need to purchase is driven by the amount of data that we need to store. We can probably reduce the frequency of the reprocessing campaigns that we want to do. And so those are some paths that we can explore. And we probably need to find what is the impacts of doing those reductions on the science side, and how can we find the balance between our science ambitions and science goal and the global situation that we need to handle anyhow. So I think that is my last slide. And yes.
Yeah. Oh. Great. Thank you so much, Fabio. Thank you so much for staying up late. This is so very interesting. So we are at the hour, but I just wanted to flash this last slide. So I think this is what Fabio just showed is a great inspiration for what we could be doing for USDF. So again, Phil has started investigating what is the energy consumption of USDF and what makes up the power mix. And the answer he got was that around 50% of the electric power mix is carbon free, but it's extremely difficult to estimate because there are many sources of electricity. So yeah, I think our point here is that we would need help to kind of support that effort of estimating the impact of USDF. Yeah. So then, yeah, we want to also to address travels, which is great that we discussed that earlier, and I agree, and I also want to go in that direction. That I think it can be a bit dangerous to talk just about reducing the carbon footprint. Like we have to take into account all the system, like all of academia. Like for instance, people have to live abroad, far away from their family. Like you can't ask those people to like never visit their family. Like that's just an example of why we need to be careful on how we present this sort of things, and also how to support people with less resources. There were some comments on SLAC as well. Yeah, and Robert is asking if we should make this annual feature of the RCW, and yeah, that would be really great. And in the meantime, you can join the Rubin Climate Action SLAC channel. So it would be really great to kind of have this sort of discussion more often. Yeah, any last question, like questions for Fabio, because we didn't have time to ask any questions. Yeah.
Well, mine is slightly more general, but applies to Fabio as well. Are there plans to share all of this info with the education and public outreach team? Because I think a lot of great things were shared, both in how much we've done and also how much we have left to do. And it'd be great to get it into informational videos, onto social media for what efforts we're going with, anything like that. Are there plans to?
Much of the NOIRLab side stuff has been put out by our NOIRLab communications education engagement team, not specifically the Rubin team. But yeah, it's a great point. We should use the resources at hand to get the message out.
Something to be proud of, I think.
Yes. And yes, I also wanted to say it's really great that the leadership is so leading the reduction of emissions. That's not the case in many experiments, so that's really great. Any other questions? Okay, great. Thank you so much, everybody, for joining. Oh, Robert, go ahead. Sorry.
It's okay. I just want to say thank you, Fabio, for this great talk, and it was really thorough analysis. I really enjoyed it. And also, I think the way you and Bob talked about it, honestly, also pointing out where we're not meeting our targets and what the issues are, this is very important and is really appreciated. And a counterexample is like, those big companies in Silicon Valley, like Microsoft, publish their annual reports, and they celebrate the targets that they're setting. But last year, they overshot it by factor 2 because of AI developments, and they don't mention it at all. So I think we're doing better here. Thank you.
Thank you all for joining remotely too.
Yeah. Thank you, everybody.